CATIA V5. This will be the reverse engineering of the following part. We're gonna see how we can also align the coordinate system. So that will be the first step. Now, to get started, I will start from scratch. So I'll go to Shape, Digitize Shape Editor. And over here, I will add the prismatic ASCII file, which will be the following. Now, we're gonna do some cleaning. So in order to do that, I will use the remove function over here. I will set this to bitwrap. Afterwards, I will click somewhere on the part, and afterwards, I will draw some polygonal shapes that will select all the elements that will be removed. So I'm gonna move around the part and clean everything over here. So let's do that. Over here, another selection. We see that there are a lot of floating elements. So when this has been 3D scanned, therefore we're just gonna have this cleaned. Onto the other side, we still have some additional floating elements. And this should be the last side over here. I will rotate the parts so that I can easily do that selection with the polygonal line. So that should be, double click to end that. And we have the following point cloud. We're gonna do a mesh, so I will select this. In this case, I will go for something like 4 for the neighborhood, 4 millimeters. We're gonna see the radius for that. And if I will hit apply, CATIA will convert this to a mesh. And this will be the following mesh. Now, the main problem is that we have the coordinate system over here. And if I will, for example, go to the top view, the part will look like this. So let's see initially how we can align this. I will go to Shape, Quick Surface Reconstruction. And over here, I will select a basic surface recognition. And I will select the method to be plane. And afterwards, I will click the mesh, which will be this one, mesh creation, and activate it over here. And afterwards, I will do a brush selection, and I will sample some elements from the top plane over here. So something like that should be more than fine. Click OK, click apply. We're gonna have CATIA draw that plane. We can also change a little bit the rotation of that. So something like this. I will also make this plane as big as the top part, even though this is a plane and it's not really mandatory. What we are looking for is the orientation of the normal towards this plane. And if I'm gonna click OK, we're gonna see that CATIA will also add that. So we have the plane defined over here, and we also have the plane normal, which will be that one. And now what we have to do is to define an axis system over here, one somewhere on the part, preferably over here where we have this intersection, and afterwards have this mesh transferred over there. So to do that, we are gonna go onto Generative Shape Design. And over here, if I will go to Insert, we're gonna have Axis System. I will click on this. And the first one, I will leave it like this. So the default with no origin selected, this will be the default. I will just click OK, and that will be the correct alignment. And afterwards, I will create a new one. And for this one, I will select the axis system to be over here, where that normal 2 will meet the plane. And afterwards, we can define the X and Y axis. So for example, I can only, it's not mandatory to add all of those. So if I will just add the Z axis to be the following one. Afterwards, we're gonna see that the Y axis and the X are not aligned. So I will just select X and have it aligned over here. We can also do the reverse if you want this to be inwards. And that will mainly influence the final position or off model to the target. So I will leave it like this. I will click OK. And now we need to do that transfer of axis. So we're going to find the following feature, axis to axis. You can also find it at the top, underneath operations, over here axis to axis. And we're going to have over here the element. So in this case, the element, I will select the mesh creation because this is what we want to align. The reference and the target. So in this case, the reference, if I want to move this towards the axis, I can select the reference to be this one, the newly defined axis, onto the edge of the part. And the target will be our initial one. And we're going to see how that part will be transferred over there. We can also hide the initial one, so that will just do a hide over here on the mesh creation. Afterwards, I can click OK, and we're going to have that transferred. And now if I will go within those orientations, so we see this will be the top view, that will be the alignment. So in this case, if I will select this axis and go over here within the normal tool, this will take me over here within the correct alignment. We can also have the possibility to clear that axis over here and make this one the default one. So over here within the axis system, we're going to see that one will be highlighted in orange. That means that will be the active one for the whole view. I can go over here on the first axis and I can make this to be the primary one, so set as current. And afterwards, we're going to see that this has taken over the orientation of our part. So this is a really important step if you do reverse engineering to properly align your models. And usually we can use axis system for this. Now, to get started over here, I will mainly create this within part design since this is a simple prismatic part. So I will go within this top view and over here for this plane and that normal, I can just hide those. I can do the same over here for the secondary axis system because I no longer need those. And over here I can start to draw this. So let's see that this should be roughly the following size. I can also add some values that will be rounded. So this should be those. I can leave that sketch. And now I have the possibility to extrude this all the way up to the surface. One solution would be to just manually go over here and see where exactly that will land. For example, 44 will be less than needed, so 55 should be like this. And if I will go with smaller steps, 52. With 52 we see that the mesh will still point out a little bit, so 53. Maybe 52.8, we're going to have a little bit of overlap. So this is one solution in order to reach that dimension. But if you want to use the information from the 3D scan, we can make the first limit up to a plane or to a surface. And we can easily do that. If I will just go over here up to, we're going to see CATIA will not know exactly what exactly is last over here because we don't have any geometry afterwards, we only have an imported mesh, and CATIA cannot link this up to last to an imported mesh, so keep that in mind. Now, in order to have that plane defined, I can go back to shape, Digitype shape editor, and over here, quick surface reconstruction. And over here I can use again the surface creation for the basic feature, and I can start selecting this. But the main problem is this will be an axis to axis transformation, and if I will try to use the basic reconstruction onto this cloud, we're gonna see that so the selected element is a result feature, it cannot be modified. So we should use the copy paste as results in order to work on this, because now I cannot select that. Okay, so in order to fix that, I can go over here on the axis to axis transformation, right click, copy, and I will come within the part body and I will paste this special, and I just want to copy the result, and the result will be point cloud number 3 over here. Now I can just hide that axis to axis transformation. I still have the point cloud aligned like I did previously, and if I will try to do the surface reconstruction over here with the planar, with the brush, we're gonna see how we can sample that. So this should be that plane. I will click OK. I will hit apply. Now the orientation is not that important since this plane is not defining length. This will be going to the exterior endless. So this is not really mandatory, but I can just rotate it and position it like this. I can hit apply. And now we have the sketch over here. But if within this sketch I will go back to part design and I want to pad this, I want to go all the way up to the plane, I can select the plane, I will hit preview, and we're going to have that pad added over there. If I want to see the measurement for this, I can go with measure between, and I can see that value. So in this case, it went 52.821. So again, you can have that a little bit changed. In this case, we also have an angle of 0.17 in this case. So the alignment of the 3D scan, we had a little bit of deviation. Usually for a part like this was made from aluminum. We shouldn't have that that alignment, but that can happen within various manufacturing processes as well as regarding the 3D scanning. So maybe that should have not been at an angle. So keep in mind that depending on the output of your reverse engineering, you can either use various surfaces over here, but you can just go directly with a pad, because for a part like this, we shouldn't have that angle defined over there. So in this case, I will just deactivate this. That means it will no longer be active. And I can go back and show sketch 2. I will just leave this as a note. So angle for the pad, and I can always go back and measure that if I want to. But now I will go with a simple part onto this one, and I know that if I will reverse the direction and add over here 52.8, this will be the resulting pad. And if I will go and measure those, we're going to see that we're no longer going to have that deviation angle. So this is why it's important when you are working with reverse engineering, because some minor angle deviations at the start will end up at the end to further increase the deviation of the part. And now we can start working on this. So since this component is quite simple, I will just add over here on the pad some transparency. We're going to mostly use features within part design to cut this, but I also want to show you how you can use some surfaces. So on this side of the part, I will create a new sketch. And over here, I will just use, yeah, let me just hide that because it will be easier to see underneath it. We see over here we have a chamfer added. So when we're going to do this cut, I'm mostly going to go for the inner section over here. This is also quite rounded, so the part didn't have those rounded fillets. Those were added by CATIA doing the meshing process over here. If I want to do a cut like this, if I will just go with pocket, we're going to see that CATIA will cut that directly. So this is something that one of my viewers recently stated. I'm usually always going for those full profiles, but we see that we can do the cut like this without any problems. Now, if we would have a more complex cut, I will just do a case study over here. Let's say that I want to use maybe a spline on this side. We can again go with the same cutting, but I just want to show you how you can do also a split that will make use of surface. So I can go over here within Jetty Shape Design. I can have this extruded. And afterwards, I can swap back to part design, and we have the possibility to use the splitting over here. So I want to split this one, which is the pad. Okay, so that will be automatically selected. So just select the splitting element, in this case extrude. We're going to see the arrow going upwards. I will click OK. and we're going to have that cut according to the spline. So for more complex parts, we can use 3D splines in order to do some splitting, but in this case, for this part, that will not be needed. Therefore, I will just delete that split, delete that as well, and I will just start work on this piece. So mostly, I'm gonna go around the sides of the part, and I will do those cutouts. So over here, I will do the following cutout. We see that line. We can also further adjust it. And if I will pocket this, I will pocket this. Let's visualize it like this. So 10 millimeters should be roughly around that. If I will go on to the other side, I will just do a new sketch. Maybe this will be at a different cut depth. So let's take a look at that. Yeah, as we can see, this will be, let's say 18, as I see it over here. 17 in this case will be less, 17.5. Okay, so again, if we want to, we can go for some specific numeric values. Now, depending on the accuracy of your reverse engineering project, you can further work on that. We're going to have the following cutout onto the bottom. So select that. Over here I can go like this with a line, but I will just check. I want to go for that inner wall, which will be somewhere over here. Afterwards, I can start with a spline, or I can use a 3-point arc. This will also add a little bit of tangency, but I want this point, the other point, and afterwards I will leave it somewhere over here like this, with a radius of maybe 11, and I will go downwards. I can also add tangency over here between those two, and I can leave the sketch, and I can do that cut, which will result within the following. So with this is more than needed, 15, 14, okay, I also need to add 1 and 4, maybe somewhere close to 30 millimeters, 13.5, okay. So I will just leave it like this. Afterwards, we still have one cut over here onto this side. We have a lot of geometry over here added within the creation process, so we're going to try to estimate where that mesh actually was. So somewhere over here we're going to see that that ramp, so something like that. I will move that point a little bit. We can add some radius over here as well, directly within the sketch. So let's add those. Maybe a radius of 5. Do the same radius over here, so 5. And again, we can do the extrude cut. In this case, with 30 millimeters, it will go like that. So I want the reverse side, the top one, which will be the following cut: 14 millimeters, 14.5 maybe, even 15. This will be closer to that. So maybe a little bit more than needed, but we can always go a little bit downwards. So something like this. I will leave 0.2 over there. And now we have some cutout elements. So over here onto this side, I can select this. As you can see, this will select the point cloud. So usually you can hide that, select this face, visualize it, and afterwards enable the point cloud, because otherwise the point cloud will be the one selected. Over here we're gonna need to see that radius estimation. So usually 3D scanners have problems with cylindrical elements. Let's try a radius of 4.5 in this case. Okay, and I will do the same. I want to have them aligned over here, and this should be again 4.5. You can further position those, but as this is a case study, I will also pad them, for example, 50 millimeters, because we don't have that information over here. For the bottom, this was mainly just used as to have the element fixed, but we had a threaded hole over here on the bottom. So again, we can try to find the location of that. Usually we can do this manually by dragging the circle and see exactly where it would best fit. And afterwards I will just have this pocketed, for example 25 millimeters in this case. And we still have the top section over here, which I will select now. So this will be the top section. I will enable the point cloud. We see that those will not be aligned, the one on the top and the one on the bottom. This is mainly a case study part. So again, we can try to find that somewhere around 6.5. So something like this should be more than fine for this. I will have that padded, 20 millimeters. And we also have one chamfer over here. So this will be fillet. I will go for chamfer. With 1 millimeter, it will be the following. So I will go with 1.5 in this case. And now I can hide the point cloud and I can check that, that model. And I can also do some analysis between those. So overall, this is the workflow that we can use to do some reverse engineering. If I will jump back to, let's say, quick surface reconstruction over here, or let's say over here, so underneath cloud analysis, we have the possibility to do this deviation analysis. If I will leave this with texture, I need to swap the visualization, so I will go over here and swap that. Now, the reference will be what we want to measure against. So I want to measure against this point cloud number 3. And to measure, I will select the last operation of the part. So that will be the chamfer in this case. So let's take a look at max values and points. I will click apply. And over here, we're going to see that deviation. So mostly we have some sections over here where, since we did that cut upwards, it will be a huge gap between those. So we see the maximum negative in this case on the interior because our initial mesh didn't have anything and we did that cut. So the 3D scanning only gave us the exterior. But if you're going to check the exterior of this, we can also sample various points by moving the mouse cursor onto those. And we're going to see how well those will match. Over here again, since we have that inner cutout, we went more than the reference because we didn't 3D scan the interior, and CATIA will say that we went 10 millimeters more over here. And that's true because we didn't have that initially. And for the middle, it will be the same. We're going to have the maximum positive since our mesh ends over here. And I went with the cut inwards. But overall, since we're mostly going to analyze the exterior for this part, we're going to see that this is quite well defined. And we're going to have some good tolerances for the exterior. Some of them will be negative, some will be positive. But overall, the deviations of the overall shape of the part is quite well. So over here in this case, we see we actually have 2 millimeters on this edge. But as this has been a sample example, mostly to get started with reverse engineering CATIA, I think that this is more than sufficient. Okay, so I will position a similar video over here on the left side, and I will also add a subscribe button to the right. So that's it. Thanks for watching.